All right, here we go with our third example with integrating trig functions to powers. So in this case, in example 3, we have cosine to the fourth power of x. And if you check out your guidelines, we're dealing with, go back here, if powers of both sine and cosine are even, so I'm looking at this third. If they're both even and non-negative, make repeated use of these identities. So we're going to use that identity right there, called the half angle identity. And we have it to the fourth power, not the second power. But we know that if we have cosine to the fourth power of x, we can replace it with 1 plus cosine of 2x over 2, that quantity squared, and that would take care of the cosine to the fourth power. All right, so we're going to replace that in the integral, dx here. And what we're going to do with this is we are going to FOIL it. So if we FOIL 1 plus cosine of 2x, multiply that through, and then in the denominator we would have a 4, we would get 1 plus 2, oops, this is cosine of 2x here, 1 plus 2 cosine of 2x plus cosine of 2x, that quantity squared, in the numerator. And we can put each of these over 4. Oops, no, I already have the square there. Dx. All right, so then we have another cosine squared here, so we have to use the identity again, and we end up with 1/4 plus cosine of 2x, 2 cosine of 2x over 2, and hold on one second. Actually, it's 2 cosine of 2x over 4. And then this piece right here is going to be equivalent to 1 plus, instead of cosine of 2x, because it's already 2x in the argument, it's now going to be doubled and becomes 4x. And over 2, but we have that times 1/4 out here. Dx. Put all of that in parentheses here. All right, so continuing on, now we have to simplify some things. If I make a common denominator of, let's see, let me rewrite this here. I have 1/4. Okay, here when I multiply the 4 times the 2, I'm going to have a common denominator of 8. So I'm going to multiply this by 2 on the top and bottom, so I have 2/8 plus, this would become 4 cosine of 2x over 8 plus, if I distribute, so I have, I can put 1/4 times, well, here, let me do this one step at a time. I have 1 plus cosine of 4x over 8. All of that is my integrand. And I can split this last piece, this fraction up, so I end up with 2/8 plus 4 cosine of 2x over 8 plus 1/8 cosine plus cosine of 4x over 8 dx. Just putting both of those, putting the 1 over the 8 and the cosine of 4x over 8. Now I can combine my like terms. I have a 2/8 and a 1/8, which is 3/8. So integrating 3/8 should be relatively straightforward. And I had a common denominator to see which terms I could combine. Those are the only terms, this 2/8 and the 1/8. So I'm going to reduce that, simplify that denominator again. I'm going to make this 1 over 2. So this is cosine of 2x over 2, and we can integrate that. And then we have plus cosine of 4x over 8. Oops. Okay, so then let's integrate each piece and split this up. I can take the 3/8 on the outside, and I just have to integrate dx, which is just going to be x. Plus, I can pull this 1/2 out. I have 1/2 cosine of 2x. Plus, I can pull the 1/8 out of here. I have 1/8 cosine of 4x. And we're going to use u substitution to integrate the cosine of 2x and cosine of 4x. Okay, first integral here, 3/8, so it'll just be 3/8 x. Plus I have 1/2. If you let u equal 2x, then du is 2 dx, which means I need a 2 here, which means I need to multiply by another 1/2 here. And so that becomes, let me go back to this color, 1/2 times 1/2, which is going to become 1/4, and then this is going to be cosine of u du, plus, for this integral, I have u equals 4x, and then du would be 4 dx. So again, I need to put a 4 in here, which means I need a 1/4 there. And then we can integrate. This is 1 over 32, and then I have cosine of u du again. But this u is going to have to go in for my u, and this one goes in. This u will go into this piece here. All right, so 3/8 x plus 1/4, and integrating cosine of u is sine of u, and my u is 2x, plus 1 over 32, cosine becomes sine of u, and that's this u in this case, so sine of 4x, and then plus c. All right, that is example 3. Integrating cosine to the 4th power, repeated use of the half-angle identities.